Okay, everyone. I hope you're all having an amazing day so far. Starting this conference, Tejas talk was really good. I always hate going after Tejas because he does such an amazing talk, and then I just get here on stage and I'm like, okay, how do I follow that dude? But let's try. So, I want to tell you some stories. But before I start telling you some stories, I want to tell you about conferences. Because we're all here in a conference, and we all go to conferences, we go to meetups, and sometimes this thing happens, which is, well, you're there, you're sitting in the audience, and sometimes the speaker says a term. But sometimes the speakers don't fully elaborate, because we have assumptions. We have assumptions when we're doing a talk. And there are things that we sometimes expect the audience to know, sometimes we don't. And this can cause some confusion. Why is that? Because imagine that you're sitting there and I just say a word, for instance, hydration, which is something that we might see today. If I say the word hydration, for some of you, you're going to think, okay, I know what hydration is. But for someone who's not familiar, you're going to think, oh, hydration, I'm going to drink a bit of water. Cool, I'm hydrating. And the reason for that is because we don't have the right mental models. That's the thing. When you hear a word, you should have the right mental model associated to it. For instance, if I say sleeping, pretty much all of you is going to have your own definition of sleeping. The reason is because you have in your mind the mental models for sleeping. Now, I want to tell you something about myself. As you might realize from my arm and a bunch of my tattoos, I'm a huge comic book nerd. I have more comics that I can read. I actually have all of these issues that are here on the slides and plenty more. And I thought, what if I picked up the things that I really like, which are the comic books, and I picked up these topics that are in conferences, meetups, that in the beginning I didn't fully understood. What if I got them all together and I built a nerdy guide to the web trending concepts? So this is where we want to start the talk, but I just want to introduce myself real quickly. I'm Daniel Afonso. I'm working as a developer advocate at OLX. I'm part of the DX team of this framework called Solid.js, a library called Solid.js. See? Thank you, Tejas. And I'm an Egg.io instructor. We can talk about all of these things after, and some other things. Oh, that's animation is really slow. Okay, cool. I wrote a book on state management with React Query. If you want to talk about state management, there was a question for Tejas early on. I have some takes and opinions on that. I did a course for React called The Introduction to the React Testing Library, and I started doing this newsletter recently called This Month in Solid, which is basically a way for people to catch up on what's been happening in the Solid universe. This has interviews, change logs, releases. For instance, the Stages podcast episode that I did with Attila showed up on this last issue. It did. See, you didn't know about that. You were there. So that's something that I started recently. A new issue comes out at the beginning of every month. So the last one was last week. But yeah, enough talking about myself. Throughout this talk, we're going to hear some stories about characters that belong to Marvel and DC. This disclaimer is here so that they don't sue me. Please don't. All the stuff they're going to hear is stories. They are here merely to educate, not to get any money or sort. So please don't sue me, please. Okay, so you still might be thinking, okay, how will this talk work? Well, this talk is completely up to you. At this point, I still don't know what I'll be fully talking about. I think I have 30 minutes, but you're going to help me figure out what we're going to do on stage. So what I'm going to do first is I'm going to set you a list of topics. And with your help, we're going to we have 30 minutes, we're going to pick 2 topics. Then from each topic, I'm going to give you 2 characters. One from Marvel and one from DC. For each character, then I'm going to ask you to clap or make some noise. And the character that has the most noise, it's going to be the story that I'm going to tell. So what's going to happen is, I'm going to tell a comic book story. That's what I'm going to do here on stage. These are not bedtime stories, so please don't fall asleep. But I'm going to tell you a comic book story with the help of the character that you pick, and then afterwards, we're going to go over the technical parts of it. The objective of the stories that I'm going to tell here is to form the mental models of how these things work. That's my goal here, is for you to have the in-between on how these things work before you know and you start implementing using these topics or learning more about it. So today, I bring to you 3 topics. We have 30 minutes, so we can only do 2. So I'm going to ask you to vote. And basically what I'm going to do at this part is I'm going to name each one of them, and I'm going to ask you to clap, make some noise, do whatever you want. Just don't throw chairs around or anything, please. And the one that has the most noise first is going to be the one that I'm going to start. Then I'll come back here after I finish that story, and we'll choose another one. All clear? Okay, so I'm going to start naming them, and I'm going to ask you to clap, do noise, whatever. So, who wants to hear a story about hydration? Oh, that's the first time this didn't get any clap at all. Wow, okay. Thank you for that clap. Who wants to hear a story about fine-grained reactivity? Okay. And the next one, who wants to hear a story about resumability? Okay. So I think this already settled the order. We're going to start with fine-grained reactivity, and then we'll come back and we'll hear about resumability. So let me just click on the link. So for fine-grained reactivity, I can tell you two different stories. And by the way, the stories are really different. They're not the same. The outline at the end is going to be the same because you're going to have I need you to form the mental models, but they are different stories. And there are some of them, and they're pretty much comic book accurate as well. That depends on how comic book nerd you are. I'm a huge one, so as you might have seen. So, we have Watu the Watcher for Marvel, and we have Batman when he's set on the Mobius chair after the Dark Side War. So, I'm going to ask you, I'm going to say the names, you clap, make noise, and that's going to be the character we're going to see. So, who wants to see the Watchers? Okay. And who wants to see Batman? I have to tell you, at this point, Watu has never won. No one has ever seen the story from Watu, yet. But Batman won today. We're going to go with people wanted. So, now it's the part where I'm going to assume a storytelling personality, so I might move a bit more. Let me see. So, after steering the Mobius chair after the events that transpired in the Dark Side War, Batman was now the owner of it. Now, might be thinking, what the heck is the Mobius chair? Well, Mobius chair is something that belonged to this old entity called the Anti-Monitor. And it allows the bearer of the chair to move through time and space. That's basically it. Now, Batman finally sat on the Mobius chair. He can see it all. He can see all that's past, all that is passing, and all that will pass. How? Well, the Mobius chair allows Batman to access this thing called time points. And they show it all. Now, there are these things called time points, like I already mentioned, and there are these other things called time derivations. Time points are basically, well, points in time where stuff happened, events happened, and past, future, present. They are holding in this single time sphere, as you can see. On the other side, there's this thing called time derivations. Time derivations are basically, I want you to think about it as time points where you changed something. And because you changed something, in this case, you're going to get a different timeline. So here we have Batman and Superman being super friends. There, they're just kicking each other. Another thing about time derivations is they are a bit expensive to do because, well, time points and traveling to time is hard. So we'll get back to it. But I just want you to keep in mind that point in time, derivations of the points in time were a bit more expensive. Now, Batman knew something. He knew that he wouldn't change the past. What happened has happened. That's what even turned him into the character that he is right now. Now, the present and the future, that's a completely different thing. You see, every time time points changes, they'll tell Batman. Batman is notified. And because of this, he can do something. He can finally act. He can save people. So he'll make sure that nothing bad ever happens to anyone else out in the world with the help of his Bat family and all the other superheroes. So let's picture a scenario. So we have time points and time derivations. There's a time point where Batman sees that the rogues are attacking Central City. So what will Batman do? Well, let's send in the Flash. The Flash kicks in. It changes this time point because he interfered. So the time point changed. There's this animation. And because there was a derivation associated to this time point, the derivation will change as well. Let's picture another scenario. Let's picture a scenario that, for instance, Mr. Freeze might be robbing Ace Chemicals. Well, what Batman will do is, once again, send help. In this case, he'll send Robin and Red Hood. They go in, they save the day, and the time point changes. And you guessed it, a time derivation will also change. Now, let's even picture the future. Let's see that Metallo will attack Daily Planet in the future. So, Batman will stay waiting for it, but when it's the right time, it will send Superman. And Superman goes in, changes the time point, and because there's a derivation associated, it changes it as well. Now, soon Batman became pretty much obsessed with solving ordinary crime even before it happened. It got to a point where the GCPD, which is the Gotham City Police, couldn't hold even more criminals on jail. There were so many. It was stopping even to the pettiest of crimes. But I told you something. The Mobius chair was for a god, an anti-monitor. And Batman is just human. So this started taking a toll on him. And if you want to know more, this story actually fits in with an actual storyline, which happens in the Justice League run from 2015 from the issue 42. So if you want to know what happens next, outside of the technical details or just from a storyline perspective, you can check this issue. But we just saw fine-grained reactivity in a nutshell. And before we start talking about fine-grained reactivity, I would just want to talk about this thing called reactivity. Reactivity is defined as a programming pattern that lets you set a behavior that will automatically react to a data change. This is, in a nutshell, what reactivity is. Now, what does it mean when you start saying, okay, let's make it fine-grained? Well, fine-grained reactivity, first of all, is enabled by this set of primitives, which are signals, effects, and memos. These are the things that allow you to have a system fine-grained. The way this thing works is basically, and I should have transitioned, exactly. What should have worked is that these primitives allows the framework to know exactly where an update needs to happen. This means that the framework doesn't need to run code to determine updates. So signals became very popular on this thing called Knockout.js, more recently with the help of Signal, with Solid. Now we started having, you can, as Tej just mentioned, pretty much everyone has signals, aside from React. Even Preact has signals. So that's a completely other discussion. But if you talk about React, React needs to run code to determine where updates happen. Because of signals, the frameworks libraries that are using signals don't need to do it because, well, the signals tell it. Let's review some code from Solid.js to exemplify very bit about these three things. So signals, in an essence, are event emitters. They have getters, they have setters, and they hold a value. This very simple example that we have here doesn't do a ton. It just holds a signal, which starts with a value 0. It returns the count getter and the set counter setter. And then we just display it on the UI. That's pretty much what we have here. And this by itself, okay, what's the powerful thing about this? Well, then that's when effects kick in. Effects are functions that subscribe to signals. And what happens is every time a signal changes, an effect is run. So what we have in this snippet here are what I like to call implicit or explicit effects. We are doing an explicit effect by calling create effect. And what we're telling this function is, okay, every time count changes, you're going to run what's the code is here. Because one thing that's very important about Solid, the functions only run once. And this is why you need this reactivity. This is why you need these models. Because if this runs once, nothing else will happen. Unless you start bringing the reactive patterns. So every time count changes, create effect will run. Now, there's another thing here which is an implicit effect. You see, there's this JSX here. And here we have a button which, when clicked, is going to set count +1. And then we have the counter here. Now, this is what I like to call an implicit effect, because what happens underneath here, the JSX will create an effect that every time it notices that count changes, it will go on, get a new value, and only replace this very specific part of the UI. And this is basically why you say these updates are fine-grained. A function runs once, and the updates only happen when the signal changes. And this is super powerful and super performant in its essence. The third thing I mentioned were memos. Memos allow you to cache derived values. Now, this is not a very heavy function that we have here, but imagine we had a function we wanted to get the double of a number. So we call a signal, and we multiply it by 2. This is not heavy at all, but we're calling this function a ton of times here. This would mean that the function would be recalled and recalculated every single time. And we don't want this to happen. So we can wrap this function with create memo. What this will do is we'll run the function once, cache the value, and every time that function is called from that point on, under the single instances of the same value of this signal, it will always return the cached value. It will only get recalculated once the signal changes. And, well, congratulations, you know all that needs to do about fine-grained reactivity. Let's recap the story, because now you might be thinking, okay, how were the mental models and what were the things you were trying to do? Well, as you might have guessed, time points are signals. They hold a point in time, which in this case is a value. I know time points and timelines might be a bit hard, but let's simplify this. Let's keep this as a point in time. Time derivations on the other side are MIMOs. They are derivations of time points. So what happened after this? We were saying that every time time points changes, they would tell Batman, because there were effects. Every time the signal that this effect was subscribing to changed, the person, in this case, Batman, would get notified. Effects. And these examples that we started seeing here, now there was a chain reaction of stuff. So every time a signal changed, Batman would get notified. There was an effect. And then Batman would also do something. He would run another effect to update that signal. Time derivations, as you can see, the signal would change. The time derivations would get recreated because, well, the signal changed. So if you're depending on something and that something changed, it would get recreated as well. So that's what happened on this part of the slides. And that's fine-grained reactivity in a very, very small nutshell. So let's just put all here on the stage so we can see it all. Reactive pattern built on top of these primitives: signals, effects, and MIMOs. Signals are event emitters, have getters, they have setters, and they hold a value. Effects are these functions that subscribe to these signals, and every time a signal changes, this effect runs. And on the other side, MIMOs allow you to cache these derived values. And this was fine-grained reactivity. Everyone clear with it? Okay. So let's get back to where we started. And we still have 15 minutes, so we can go over resumability pretty well. So for resumability, I'm going to give you two characters as well. One from Marvel and one from DC. So from Marvel, we have our friend Iron Man. And from DC, we have our friend Lex Luthor. So you remember the drill? I'm going to tell you a name, and you have to make some noise. So, who wants to hear a story from Iron Man? Yeah! Okay. And who wants to hear a story from Lex Luthor? Okay, so guess Tony Stark wins this one. Okay. Fun fact, Iron Man hasn't been picked in 6 talks that I did this presentation, so that's going to be interesting. Let's figure out. No, everyone wants to see Lex Luthor when they get there. But there's a reason for that, and I'm going to tell you. The hydration story has the same characters. So usually what people do is they pick Iron Man on the first one, and then they say, let's see if this dude is not cheating us, and if he actually built the stuff that we need. But yeah, let's get back to the storyline. So, after last saving the world and against a huge fight over this dude called Kang the Conqueror, Tony Stark found himself with an issue. You see, he completely ran out of armors. They all went down in fighting. You see, fighting these big bads is something that takes time, money, and armors as well. Now, Tony was exhausted. He just got back home. This huge fight took days, and he needed his well-deserved rest. But as he was about to fall asleep, he asked Friday, which is his custom AI assistant. If you follow the movies, it's Jarvis. It's the same thing. In the comics, it's called Friday. And he asked Friday, please remind me tomorrow to start building my new armors. I'm gonna need it. I'm Iron Man after all. And he fell asleep. It was a well-deserved rest. We all like falling asleep after doing a ton of work. But suddenly, something happened, an explosion. You see, this bad guy called the Mandarin couldn't let this opportunity go. It was a vulnerable Tony Stark after all. The dude was drained, he had no armors. I'm gonna go after him and I'm gonna finally defeat him. It's his nemesis. That's the thing that bad guys do, apparently. So, yeah, the Mandarin shows up. Okay, I already said that. So Tony wakes up and he's startled. You see, you were sleeping. That's the thing. You're sleeping. If something happens, you get nervous. And you wake up, okay, I need a suit. I need to figure out a way to get out of this thing. So he thought, probably I won't survive my old manufacturing process. You see, the old manufacturing process that Tony had was, well, he built the armor in his manufacturing with the help of his custom AI, but with the help of Friday. But then what happened was, after he had the armor was not working immediately. The armor was not interactive. So he had to do this process where he would upload Friday into the armor, and Friday would boot up the armor from the inside. That's the process that Tony had in the past. Now, this would mean he would get captured. And as you can see, some Hydra goons were showing up in the back. He was nervous, like, okay, think, I need to figure out a way to get out of here alive. So, he thought, I need an armor that's immediately ready to work. Friday, initiate resumable protocol. Build me a suit now, I need it now. So, Friday started doing it. Friday plugged into the manufactory and started building a suit, but now there was something different. While building the suit, Friday was doing this thing where for each part of the armor that needed some sort of interactivity or information or stuff that needed to happen, Friday was encoding this extra information there. And this would tell this extra information, but it would also tell Friday where to get the instructions to run this specific part of the armor in case something happened. And this led to the end where the armor seemed to be ready. Now, while this was happening, the villain was doing his bad guy monologue. You know, you've watched comic movies. They just talk and talk and talk, and it seems like nothing is going to go everywhere. But as he was finished his monologue, he pointed his hand to Tony, and he fired from the 10 rings. But as he does that, a huge explosion happens, and Tony jumps, and as he jumps, an armor flies underneath him and catches it. How? The Mandarin was startled. He didn't believe that he would get an armor that quickly. He was like, what the heck? How? There's no way your old process would allow you to do this thing. You see, something different happened. In the resumable protocol, Friday did something different as well. When it created the armor, it already uploaded a very, very small part of itself into it. And this very small part of Friday would be able to listen to instructions, look at the encoded information that it added there, and figure out on the fly, okay, this is where I can get the instructions to run this specific part of the armor. So basically, there was a small Friday running inside of the Iron Man suit. So, oh, and something that's very important that I forgot to mention you. There is no boot phase. There is no need for the armor to not be interactive and having all that power up from the inside. The armor is just ready to work with a very small nuance. But let's get back to the story. So now Tony said, okay, Friday, fire the rockets. And Friday said, okay, powering the rockets, Tony. And after a while, the rockets were ready, and Tony just sent this huge blast that destroyed his entire place. But this gave him an out. It gave him a way to escape there and finally ask for help, because the way that the armor was working, he couldn't survive a fight with the Mandarin. So he just flew away out of there. Now you might be thinking, okay, what's next? What's the rest of the story? Well, you have to stay tuned for the next issue, because that's what happens in the comic book world. Sometimes you're listening to us, reading an issue, you finish, you have a huge cliffhanger, and you're like, okay, what the heck is happening next? I want the next one, and then you have to wait months or weeks. Okay, but this was Resumability. This was Resumability with the help of our friend Tony Stark, the Iron Man. So let's figure out what happened here. So Resumability is there, and by the way, was popularized by this thing called Quick. It's basically the use case of resumability right now in the market. And resumability is there to fix one problem, which is hydration. When we get a web page, the page is not immediately interactive. And during hydration, we are redoing the work that we did on the server. That's basically how hydration works. Ideally, we wouldn't have any hydration at all. And I say that as I'm drinking water, okay? So, this is how it happens. On the server, we generate this HTML, this static HTML, but there's this difference. We're also serializing some extra information on the parts of the HTML that needs to be interactive. Okay. And what will happen is basically, because we're serializing that information, it allows, when we get the page from the server to the client, it allows us to resume the execution. So it means that the page that we get here, it's immediately interactive. We can immediately click here. Now, you might be thinking, okay, but how do we know the JavaScript to run this part? How does it happen? Well, What happens in Quick is we also get this very small thing, which is like around 1 kilobyte. That's called the Quick Loader. And the Quick Loader on the client, what it does, it sets up this global event listener that every time an event is triggered, it intercepts it, looks at the serialized information and figures out, okay, this is where the JavaScript I need to execute this specific part. It downloads it, and it runs it. And this is basically how resumability works in a very small nutshell. So let's look at our story and try to piece this a bit together. This was the issue. Iteration is slow. That's the old armor process building that Tony had to build a suit. So once he started getting invaded, he said, okay, I need a new armor, so I need a new page. Friday, in this case, Friday is the framework. The server will build this new HTML page, serializing all the information it needs to resume its execution in a new environment, and sends it to the client. So the client gets the page, and it's immediately interactive. Now, the client will also get the Quick Loader. That's why I was telling there was a very small version of Friday that gets uploaded to the armor. And the Quick Loader will set the global listener to all the events. And what will happen is when an event happens, it's basically what I said. Quick Loader intercepts it, downloads the JavaScript needed to execute it, and runs it. Now, some of you might be thinking at this part, okay, but how is that faster? Because you're still downloading JavaScript, and now you're just delaying the download. Well, Quick also has this thing that runs in the background in service workers that allows you to basically know how to when to prefetch the specific JavaScript. So it starts optimizing earlier. So once it figures out, okay, you're probably going to need this JavaScript, it just starts fetching it for you. So when you click it, it's already there. So it offloads some of these computations to a service worker. And this was resumability. So it fixes the problem of iteration. That's basically, in a nutshell, what it is. So once a client requests the page, using the framework, the server will build new HTML, serialize information on how to run that specific part, and once the client gets the page, it's interactive. The client will also get this thing called the Quick Loader. And the Quick Loader will set the global listener to the events, and when an event happens, it's responsible for getting the specific JavaScript. And this was resumability. So we can go to the last slide because I'm almost getting over time. We already seen this slide, but it's a different thing here. Because you might be thinking, what are the next topic? I showed 3 of them. There's more. But I would like you to help me on that, if you would want. If you have ideas, if you have topics that you would like me to do a nerdy guide for, let me know. I'm all up for that. Hopefully you enjoyed as much as I had fun doing this. It's telling stories, it's nerding out, but it's also telling technical concepts. So, for that, stay tuned for the next talk, and I'm Daniel Afonso. Thank you so much.